Did it explode?
I think so.
I hadn't unmuted the mic though, so you said that into nothing.
It did nothing? Aw.
I hadn't unmuted the mic.
Hi.
Hello, everyone. Welcome to Code School Season 2.
Episode 7.
Episode 7.
We're on a roll now. We're on a roll.
Practicing some dynamic RAM.
Yes, so last episode, because it was a kind of a big subject, so I decided to split it into 2 episodes. So this is the second half of that. I'm going to do a little tiny recap in the beginning, then we'll go into practice, and then there'll be a little thing at the end.
A little thing at the end?
Yeah.
It's called homework.
Then we have 2 things at the end.
Woo!
And the homework today is a doozy.
Oh,
because I'm expecting a bit more now from you.
I think for me, at least, you should set your expectations as low as possible.
It's fine. I can hear you cursing all week then. Good stuff. So we go?
Yes, we're going over to you.
Mm-hmm.
Bam.
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 That's not me.
That's on a roll today. Here we go.
You with buttons today is like the best. So high Gabe equals new high.
Okay. High.
High. That's what we learned yesterday. Actually wrong.
Yesterday. Last week.
Yeah, last week. So tell me where the bug is in this one. There's a bug here.
I mean, I don't know.
I never had a question in this one. I thought I would
now I'm confused.
do a little twist. So it's supposed to be a star, high star, Gabe.
Oh yeah, because that's how you tell it to point to something else.
Yep, there we go.
Yeah,
good.
Yeah, see, I remember a little bit.
A little bit. So last week we learned about dynamic memory. Good. This week we're going to do 2 things. So I'm gonna talk a very short bit. We're gonna practice. We're gonna go back. We're gonna talk a little bit more, and then if we have time, we're gonna practice that as well. And then homework.
Yeah.
Cool. We're gonna practice using dynamic memory. That's the first thing. Play with that a bit. And then we're gonna learn about the most important feature of C++.
I'm gonna sit up for this one.
Yeah, it's the most, or in my opinion, it is. I know that many others agree with me, but this is the feature. Like this is the thing.
Feature.
This is the thing. And this is kind of what we've been building up to, because explaining this feature in the beginning, it kind of doesn't work because you need a lot of the context that we've been going into of why you need to do that. Ready? Cool. Let's go. So short recap. This is from last week. So if you want to create a pointer variable, you do int star health, for example. You could do, and then to give it, to allocate dynamic memory and to give it the memory address of that dynamic memory, you would then say health is equal to new int. Like we saw in the high Gabe, you can do this in one line. So you could say int star health equals new int. That's fine. And you can also, because int has a constructor, if you think of it like a class, you can say int star health equals new int, parentheses, and the number you want. So we can even, like we do here, we do star health to go to the memory address, or to go to the dynamic memory and put a 50 there. We can do it all in one line. Like all of these 3 lines, can you do in one line? So you can say int star health is equal to new int, parentheses, 50. So you're allocating memory and also putting 50 there. So that's kind of nice, instead of doing 3 lines. But you can do 3 lines if you want. That's fine.
But then when you say, so if you have int star health is equal to new int 50, does it know that so how does it know new int is health? Because we're saying it's equal to that?
Think of it as 2 steps, and you're doing the right step first, and then you do the left part of it.
Okay, but then how do you know, because new int is very like...
New int is allocating on the heap memory, and we get back, if you think of new int like a function, it returns back the memory address of where this dynamic memory is, and where do you want to put it? We put it into the health variable.
Okay. Because I was reading it as like...
Read it backwards.
Yeah, okay. Because I was like, we're giving health the name new int, which makes no sense because int is something that's used in a lot of other places. So are we going to end up calling it something else, or is everything just going to be this value?
So int is the type that we want.
Yeah.
So you could do new double, new float, new bool. If you make a class called player, you can do new player. and then it will always allocate new of the type that you want.
So it's basically saying, so it's returning whatever is in the heap to the new int, and then assigning that to health.
Yeah, so if you read it backwards, we want an int, we want to new it, which means we want it from the heap.
Yeah.
Where do we put it? In the
health. When you call it new, that means it's in the heap.
Yep.
But we used that. So we used that before with like health equals new health.
We used that in season 1.
We also use it, I think, like not last episode, but episode 5, when we were doing classes.
No, we didn't new it. We never knew it.
Really?
We said health and then something, or play or something. I'm pretty sure we didn't new a thing. Let's continue.
Okay.
And then because you were asking for memory, you're asking for dynamic memory, you need to tell the operating system when you're done. You need to say, I'm now done with this memory. I don't need it anymore. You say delete health. And it's then that's totally fine and that's totally safe. There's a question here. I forgot why you put the star on the second line that way. Instar health versus it doesn't matter if, so this is a formatting thing. Some people say int star space health, and some people say int space star health. Okay? I do it this way, and many others do it this way, because you think of this box here, int star. This is a pointer to an integer. If you read it backwards, it's a pointer to an integer. If you have the space on the other side, it's like the star seems to follow the variable, which, like here, it doesn't always do that. So here, there's nothing to do with a star. Here, there's nothing to do with a star. It's only when you dereference the variable and only when you refer to it as a type. So that's why I feel like you could do it either way, but it's a more formatting thing. Okay? So let's practice. Let's switch over to the dual view. I think I had it up here. I think I had it up here.
We do 200, no. What's our zoom level usually?
I'm going to make a new file because you have a file and I don't. Main CPP.
100 might be too small. 150.
What was your zoom level at? I'm at 200. Let's just see how this looks like. Return 0.
I'm just going to hide my little source explorer thing as much as possible.
You're at what, 150?
Yeah, 150.
150. Yeah, seems to be okay.
Return 0?
Sure.
Ah. Return.
Let me hit F5 just to see if everything's working.
Oh my god.
Your keyboard is...
So how to type.
Okay. Seems to work fine. System is happy. You're doing F5 too? Yep, you get the thing?
Yeah.
Cool. Okay. So let's start with the most simplest example. Let's just do what we've been playing with. So int star, let's call it health. Let's do it in the different steps just to see that. So I just do int star health, and then I do health is equal to new int, and then I say star health is equal to 50, and then it was delete health, like that.
So if I understand this, so we're creating, first we're telling it to go, that we're creating int health, but we're saying that the int is in the memory. Like we're pointing to something in the memory first.
So first,
yeah.
If I just zoom in, just so we have that a little more. There we go. So this, and only this, is a variable on the stack.
Yeah.
Ignore everything else. There's nothing on the heap
And the
yet.
stack, just as a reminder, the stack is everything that's going, that's just like everything on, like, I don't know how to explain
everything in the program that is
Yeah.
just, it keeps growing and shrinking.
Basically everything that we've done up until now has always been
On the
theoretically in a stack.
Yes,
Okay.
yes. We've never been dealing with the heap. And then, so that's the variable. It's here.
Yeah.
Here, a little bit of highlighting, but okay. But if you think of this one here.
In line 4, yeah.
Yeah, just this part, the one I highlighted. This thing says, I would like some memory on the heap, and the size of the memory, how much memory I need, is this much.
In int, which was 4 bytes.
4 bytes. Yeah. So when this, if you think of it as a function, when this function returns, it will return as a memory address, which is where on the heap we got this memory. We don't know where that is. That's up to the operating system. Where do we put that? We put that in the pointer, because a pointer is just a variable that stores memory addresses. Yep. So then we say star health. And star health means like if we do this,
Yeah.
and you can do this,
Yeah.
or it's going to yell at you, but like, trust me, you kind of can. You're saying, I want memory address 50 to be in health.
So it's like a very specific thing.
Yeah, because pointers only deal with memory addresses. There's nothing else in a pointer. It's just the address of where it is. So we want to take the memory address and go to that location. And there, when we're at the location, there we put the 50. So this is that. It's called dereferencing.
Okay.
So you have a reference here, and you're dereferencing that. So this means wherever health is, go to that location and put 50, and then put in 50.
Put 50 in the heap.
Yes.
So it's not telling it to go to a specific memory address.
Mm-hmm. Go to the memory address that health is storing.
But how do we know which one health is storing?
We got that from NewInt.
Oh, okay.
Because we're assigning, we're saying health is equal to whatever NewInt returns, if it's a function.
Yeah.
NewInt returns a memory address, we put that in health.
Yeah.
Then now health is storing some memory address. Go to that memory address and put 50.
Yeah.
And then we're done, delete health.
Yeah.
Okay?
So then theoretically we can assign just that memory address to something else later.
Ah, yes. You're ahead of us in the practice. Yes, we are. Yes, you can.
Yeah.
Okay. Yeah, because it's just a memory address.
Yeah.
And as long as you know where it is.
But at the end of this, we delete it.
Yes.
So it wouldn't exist there anymore after this.
You could, before you delete it.
Yeah, do other stuff with it.
Yes.
But, yeah, okay.
So let's put a breakpoint in every single line here, just so we can play with this a little bit.
Oops.
Mm-hmm. Let's hit F5. Now this is a weird view for me. I don't need this. Yeah, something happened with the view.
All of our Visual Studio reset, basically. Like everything that we had kind of done before, because we had to log in with accounts.
Let's...
Our trial period extended, or expired.
Okay, so we've executed this line here.
Well, very important.
Mm-hmm. Oh.
No, I messed it up. All right, we're good.
Mm-hmm.
Kind of. Close.
So, you can see that we've passed this line because we have created a pointer on the heap, no, on the stack.
Yeah,
it's important that I don't confuse these. I might do that. So you can see here in our locals that we have a health, and what is the value of health? Junk. It's a junk, and we can click this little thing to ask, like, hey, what is at that memory address? And it says unable to read memory, because this is just nothing, because we haven't assigned it to anything. We haven't actually gotten a memory address there. Okay, so if we had F5 once, then we see yeah, but it's a different memory address. You see, usually memory addresses are thought of as a 0x something. It's just a hex value.
Oh, that's what a memory address looks like?
Yeah.
Okay.
It's just a number.
I've seen that in random like error log files and stuff like that. I'm like, I don't know what this number means.
It's a memory address.
Okay.
It's just somewhere in RAM.
Interesting.
It's just a location in RAM.
Never knew that.
And we just got a location in RAM. What's location? That was determined by the operating system.
Thank you, operating system.
And what number is there? Because it's an integer. What number is there already?
One of the random numbers that is very large. It's the maximum.
No, it's just some random number.
Oh, really? I thought that was like the lowest it could go.
No, because
on the scale.
Someone in this operating system was using this memory. I don't know, some program.
Who was it?
I don't know.
Who's been using this computer?
Some program. And it's not using that memory anymore. We asked for it, and we get the junk that is left behind.
Wow.
Yeah.
Rude.
And the cool thing is, this might not even have been used as an int. Someone might have asked for a big chunk of memory, used it for something, and then it's not using it anymore. And now we just got a slice of it. We just got a little part of it. So never ever read into what's there. That's not going to work. But you can see that health is equal to new int. The only thing that happened is we got a memory address. We got one. Okay. So if we hit F5 once, you see the memory address didn't change. The memory address is the same, but we put 50 in that location on the heap. So int star health is still pointing to the same memory address.
But now it actually has a number that makes sense.
Yeah,
Because we've
so-
told it that.
Our pointer is on the stack. It is pointing to something on the heap, and on the heap is now the number 50, but the pointer still didn't change. Still the same pointer. And then if we had F5 once more, we've deleted. Now health is
Now
just,
it can't read. It took away its reading ability.
yeah, it just gave it
It's
some
like
other
me.
value. Yeah, it's gone.
Can't read.
Can't read. It's not used anymore.
Poor memory.
Okay, and you had an awesome point. So if we close this, the thing was, could we give that pointer to something else? Right? So let's do this in one line now. So new int, and we can say 50. Right?
Then we can get rid of like this.
These two, because it's the same. Okay. And what we can do is we can say int star. Let's call it. What should we call it? Let's call it other health.
I was gonna call it bad mixer.
Bad mixer. Let's call it other health. And here's the thing. Now this confuses people often in the beginning. Since they're of the same type, they're both int star. You can just say is equal to health. Because what is health storing? What is on the stack? Don't think about heap. What is health storing on the stack?
An int.
No.
50.
No. What is health? No, sorry, this variable here on the stack, what is it storing?
Health.
No.
Memory address.
Yes.
Okay. Took me a second.
Yeah.
Yeah. Memory address.
Okay. What does this one want to store?
Value?
What type is it? It's an int pointer.
Yeah.
Mhm.
So it wants to store an int.
No. It wants to store a.
I don't know, memory address?
Yes.
Okay.
Pointers want to store memory addresses. Nothing else.
So we're saying, this is saying,
Let this pointer store whatever this other pointer is storing, which is also a memory address.
so we have two pointers now.
Yes. And they're pointing to the same place.
Okay, so we have int star is the pointer,
Mhm.
and then we're assigning that, we're giving that, it's calling that health,
Mhm.
and we're giving it an int value of 50.
Yeah, we're
On
asking
the-
we're
on the
asking
heap.
and we're asking for a new memory address on the heap.
Yeah.
We get the memory address, we store it in health.
Okay, and
Mhm.
then we create another. Okay, so it's not.
It's a copy.
We're basically just we're creating a pointer that points to something that already exists.
Yes. So
Okay.
so if you some people like it visually.
Give me some paint.
Some people like it visually. That if that's not the thing I want. Note that the stack and the heap aren't two different locations, two different memories. It's the same memory, just in a different location, but it's easier to see it this way. That if you think of the stack here and the heap here, right? What we just did was we created a value on the stack. This is health. And it, let me do a brush, boop, and it points to a thing.
This is fantastic.
On the heap,
Yes.
somewhere.
Yes.
We don't know where it is. It's just somewhere in the heap. And what we just did was we created another thing on the stack, but that other thing is pointing to the
because it's both pointing to health.
to the new int that health points to.
So just again, so I can process this in my head,
Mhm.
we've created a pointer that's called health
Mhm.
that points to an int
Mhm.
on the heap,
Mhm.
and we're storing 50 in that.
Mhm.
And then we're just creating another pointer, but we're calling it something different.
Yep.
With health. So in the end, that's pointing to health.
Yep.
Because health is the int value in the heap.
Yep.
So we could say also underneath, instead of doing all this, we could just refer to other health.
Yes.
And it would be referring to that spot.
Bingo.
Okay.
Absolutely bingo. Yeah, because we could then now just say, use all our operations that we did on other health. So for example, we could do star other health is equal to 60.
Yeah.
And then we could do delete on other health.
And that would keep health there.
No,
No.
because they're pointing to the same. We're deleting the heap part of it.
So only one of them. Okay.
So let's put breakpoints and see this in action.
I need to write this down.
Yeah.
Whoops. Oh my god, I can't type.
And then you, delete all the health. Okay. So let's run this.
I need to put 6.
So we have health and other health.
Yeah, it's confused again.
Confused again. That's fine. Now, and remember, it's in my case, it's C4 FA0 for me. What is it for you if you hit F5?
Oh.
Or
E9.
you went 2 steps, but that's okay.
Well, I forgot this one.
Yeah.
How do I go back again?
Yeah, just kill it and start again.
How do you kill it again? I got it. I have 184 FF8.
Yeah. And then if you hit, so we're here. If we hit F5, you'll just see that other health is just copying the memory address.
Yeah. Yeah. So they're exactly the same.
Yeah. But here's the cool part. So you see health is pointing to, has this memory address. Other health has the same memory address. Cool. If we hit F5 now, where we assign the value, you see that both of them update because both of them are pointing to the same location.
Is there a real world example where this happens often?
This happens in all applications all over the time.
Oh, okay.
Oh, yeah.
I was like, maybe this is just really unique.
No.
Oh.
The 2 things pointing to the same thing. Yeah, this happens very much. If people are sharing data, you have 2 threads that are sharing data. That happens. If you have, a quick example is maybe, well, UI uses it differently now, but you could do it that way where if you have your health in like the group window, but you also have your health in your main UI, and it wants to be the same value, it could just be two pointers that point to the same. Modern UI does it differently where they just copy the value. But you think of it that way. But you see, we delete only other health. And
they're confused.
Both of them go away.
Oh, we have the same numbers.
For you?
Yeah, ours are the same numbers.
We're in debug, so you might do something a little different. So debug usually tries to keep things the same.
Okay.
Yeah. So here's the thing. If we delete health also...
Deathly. my typing is just not working.
Yeah, because delete and new are operations on the heap.
Yeah.
So if we delete...
So you'll always know that delete and new, they're never assigned to anything else.
Yeah, they're just used for heap operations. Okay. Yeah. So we go through, and then we want to delete health. Ba-bum. Yeah. We crash.
No. Yeah. Is that our first crash?
Yeah, I think so.
What is that?
Yeah, right. Yeah, it's a crash. And there should be here on my side, this is a call stack. And often if you're like playing a game or something crashes, you might get like a reference to what might crash, or if you want to send something to people, like
this is like who crashed to see why I got a blue screen.
Yeah, this is that. So because we tried to delete a thing that was already deleted.
This can't divide by 0.
Yeah, so you have to be careful in that sense. So yeah, even though we're deleting other health, because other health pointed to what health was, we can't delete that again. And I want to show you then one other trick here. And yeah, you can, like, this could be double, this could be, whatever. It could also be like if you create a class, struct player, and then you give that just a regular...
Should I do this too?
No, I'm just showing. So if you do this, like I created a class called player, it has a health, okay, great. That, I call it player P. Let's not do that. So now I've created this on the heap. I've created player on the heap. And what is player? It's just a class with a health. We could then also do this. And then all of the constructors and all that stuff that we did before. It's just saying that I haven't implemented it. So now I'm creating player on the heap. So I'm not only asking for the 4 bytes on the heap, I'm asking for whatever this is. And the pointer will then point to a place in the memory for the heap where this is stored.
So you can just hide everything in the memory.
You can put
everything in the memory.
You can put all your stuff on the heap.
But you still need to delete it afterwards.
Yes. So you need to do delete P. I just called it P because I didn't want to go off the screen. I could call it Gabe. Gabe.
No.
No,
don't delete me.
I'm going to delete you.
No. No.
So I can show you just a quick builders.
Because of the player.
Oh, didn't I save quickly? What?
Isn't it because
I have it implemented.
Player was unassigned.
Yeah, I have it implemented the constructor. There. That's fine. I don't care about that. So Gabe again points to nothing, but it knows the type. It knows that it's going to be a pointer to a player, so it knows that it's going to have health and damage. So this is helping you, but we can't read the memory. So when I initialize it, health and damage, like everything else, just get a garbage value. And then I could assign it.
Yeah.
And to do that, I do Gabe.damage, and look what it does. You see, it's not...
Why did it make an arrow?
Yeah. So here's the thing. Gabe. Remember we always did dot to do the thing? But the thing is, so this is a quirk of, or design of C++. If the thing you're accessing is in the heap, remember you always need to do the star.
Yeah.
Yeah. So you would have to do this, and then, and you'd have to do it this way, and then you can do damage is 50, and then Gabe health is 100. Let me just show you this. So now you can see they have 100 and then 50 for damage and health. But this is kind of awkward to write.
Yeah.
And the reason why you can't write this, so it will yell at you, because it's thinking you're actually doing this.
Which doesn't exist. We haven't assigned.
You're asking to dereference the Gabe.damage.
Yeah. But we haven't ever referenced that, right?
Yeah, and it's also damage. It's not a pointer.
Yeah.
It's just a regular number. So you can't dereference that. So this is kind of awkward to write, right? So instead of writing this, you can do the arrow. It's the same thing. There's no difference.
So if I try to read this now, just to understand it, if you can scroll up a bit just to the... So we've created a struct, which is just generally like a template of something that exists, right? Then that has int and health, int health and int damage. So it's holding two values of health and damage. I forgot again what the player is.
It's a constructor.
Okay, the constructor.
It's the function that is called when you create the object.
Okay. And then we have to create the object actually outside of the struct, which is the player.
Yep.
And in main, then we're pointing player because the struct, which we're referring to as the struct player, we're pointing to that in the memory, giving that the name me, and then calling it new player.
Yeah. So
and then we're giving it inside the memory heap the value 50 and 100.
Exactly.
And then you're just deleting me because you're rude.
Yep.
Okay.
Exactly. So we're asking for memory on the heap. How much memory? Whatever fits player. Yeah. Okay, cool.
And we know whatever fits player because we've made player before.
Yeah, it's over
here. So the
the
operating system will know how much memory to ask for.
Exactly. Yeah.
Oh my god, I don't understand how people made computers.
Very slowly and carefully.
Like, what?
Very slowly and carefully.
But this is like, because I'm trying to imagine, I ask you, hello, can I have part of your desk? It's going to take me time to roll over there.
Yeah.
And sit by your desk. And this is like, you can't comprehend how fast it's doing it.
Oh, it's very fast.
I don't understand. How did we get to this point?
And
Where did we lose our way?
So that's a pretty cool thing. So if we have, here's the constructor, the player. Let's say we take in a damage, for example.
Yeah.
Like we've done before. So damage is equal to a damage. There's no difference here. I need to put that in the header as well. So we have the constructor now here. Now this is going to yell at me. You're like, why? because it wants
damage.
Yeah. So let's say the damage is 50.
Oh, it actually wants a value.
Yeah. So now I can actually construct it this way. So if I do here health, and then health is equal to a health, and then I do that here as well. It's going to yell at me again because it needs 2 values. I'm only giving it 1. If I give it 150, it's happy again. So now I've done this all in one line. So now you see again the importance of the constructor, because now when I ask for it in the dynamic memory, this is actually just calling the constructor.
So, but the constructor is deciding basically what the player is.
Yes.
Because if I remember before, the class player, that's just a framework.
Yeah.
And the constructor is basically like if we have a zombie, we want multiple types of zombies, and the constructor, the zombie template is in the class.
Yes.
But then we use the constructor to say this is a fast zombie.
Yep.
This is a slow zombie.
Yep. This zombie has this much health. This zombie has that much.
So
health.
technically, I mean, it could be like player : and then whatever name, zombie 1. Or where do we name each constructor?
So
does that?
You can have this constructor. You can make more constructors.
Yeah.
It can also just be what you send into the constructor.
Yeah, I'm just wondering template wise.
Yeah.
That you take when you make a constructor again. It's player. The first player is referring to that class. So this is a constructor of that class.
Yep.
Then you have the 2 semicolons.
So yeah, this is the class that we're talking about.
Yeah, and then when you name it player, that could be whatever name we want.
No, that just means that it's a constructor. If it's called the same.
Yeah.
If this function, if you think of it that way, if this function has the same name as the class you're referencing, then it's a constructor.
But then how do we? So if we wanted to make another player, how would you make it not the same? What does that look like?
So if I do player star Ole is equal to new player, and I have 200 health, but I only do 1 damage. See?
Okay. So you're basically just calling.
I'm calling the same function, but with different values.
Yeah, and a different name.
Yeah, the variable has a different name.
Okay, because I think in the example, the zombie thing I was trying to get to before is that you can create multiple, like, what are they called? Constructors.
Yeah.
Based on the same class.
Yep.
But what would that look like if you were to create another constructor that's tied to player? What would that look like?
Oh, so I can make a constructor that only takes in health, but doesn't take in damage, for example.
Yeah.
I can, if I copy this guy, I take away damage. Let's say that means that the damage is fixed to 50.
Yeah.
So if you only give the health, the damage is 50. And if I now remove this one, so now the first one, which is you, is calling this constructor because it has 2 arguments.
Yeah.
Doing 2 arguments.
So it's based on the arguments that it knows which one is. But
Yes.
what if you have a constructor and 2 of them have 2 arguments, or is that an issue? You can't.
That's an issue.
Okay.
Yeah.
Okay.
Yeah.
Because I was trying to imagine in my head trying to make like a zombie horde that has like 50 different zombie types.
Yeah, you can do different types. Like it doesn't even have to be an int you send in. It can be other things. You can send in a name. You can send in. There's a thing called an enum, which we'll go into later on.
But it's just a number of variables. What if we have different names of the variables?
That doesn't matter. It's the think of it as this is the thing that matters.
Okay.
Yeah, you can actually you in this part you don't have to name the variables.
Okay.
You only have to name them here. So some people do that, but I don't. I like having it the same. Kind of looks symmetrical. Okay. So there's one thing I just wanted to show you with this. So if I do, I'm going to do this. I'm going to create 2 pointers. And this is just for an example as a way to kind of understand what's going on. So I'm creating these 2 pointers. I create a scope of some sorts. We can even delete this just to simplify the code a little bit. Yeah, I can have that. So in the scope, I'm saying, no, let's be even more fun. Let's be more fun. So we have a function. Let's call it generate. Okay. And that function returns new player that has 100 life and 50 damage. All right? And now, me, I am the result of calling generate. Okay?
Okay.
Think of it also like if you do player star Gabe is equal to new player. Oh. And then we return Gabe. Okay? I'm just allocating the memory, putting it in a pointer. I'm returning the pointer.
Yeah.
So I'm just, this isn't returning a player. This is just returning a memory address. So generate gives me a memory address. What do I put in the memory address? I put it in a pointer. What is the type it wants? It wants a player star. So here we go. So
but for this example, we just ignore whatever's above. The A health and A damage.
Yeah, it gives you 50 and 100.
Yeah, I'm looking above, like in line 10 to 13. We just ignore all that stuff.
Well, this is the function. So this function here, because it has two arguments, calls this one.
Ah, okay, yeah, okay,
yeah. So, but a shorter way to do it is because we don't need to name it. We can just return the new player because someone is going to receive it on the other side. So there's a problem with this code, and this often happens, and this then goes into our second part. So if I do this and I run it,
well, it doesn't delete itself first of all.
Yeah, you notice the problem. There's no delete.
Yeah.
I do this and then I return. So what happens if I do this? If I create Ole, I do something with it, and then later on I can say Ole is equal to, oops, I did not want to do that. All right, Radion, what button was that? What?
I have no idea.
Are you open down there? No? Okay. All right.
Magic.
I call generate again.
Yeah.
Okay. So here's a problem. This is the bug. This is a memory leak.
Uh-oh.
Yes. Another way to watch it, if I do it even simpler, we don't have to do it in a function, is this. This is a memory leak. I am asking for memory. I am putting it somewhere.
Yeah.
I am then asking for memory without deleting the old one. So here I have to do delete Ole, and then I can use it. Then this is okay.
But how does it... Oh, I think I'm just completely lost. How does it know what the new one is?
Let's ignore this guy.
Okay.
We've known this. This is the episode today. Is we create a player.
Yeah.
And then we use it. Look at the health, look at the damage, do something, whatever, and then we delete it. We're happy. Great. And then some code happens, and then later on we say, because the pointer is still there, it's just not pointing to anything. So I say, I want a new one. I want to point it to I want to use the old pointer.
But you don't need to have the asterisk on the new Ole somewhere.
Yeah, because so Ole is a pointer.
Yeah.
Ole as a pointer wants a memory address. This thing returns a memory address.
Oh.
It's only when I want to go to the heap.
But technically, couldn't you just say you equal new player, or do you have to have those values in there?
Because the constructor we have takes in two values. That's the only reason. Because there's only one constructor to call. So this is okay. This is a memory leak because we didn't delete. So for every, basically, there's a pair that's happening here. For every new, there must be a delete. Like for everyone, there must be the other. So if we would run this, we would leak, in this case, 8 bytes of memory every time we run this. And if I would put this,
is it just going to crash super hard?
I'm not going to run this because this computer will probably crash.
Do it.
But you can do this at home. But please note that I'm not responsible.
I take no responsibility.
But if I would do this,
it would just delete. Well,
it would be better. There's still one memory leak happening, but it's so small. It's still 8 bytes, but it's fine.
Yeah.
We didn't delete the first one.
Yeah, but because basically the while has no end.
Yeah,
Like we don't know if it's true or not. It's just true.
it will run
So
forever.
it's always doing it.
So this is okay. We still leak memory.
But 8 bytes is
8 bytes
not
instead
much.
of infinite forever. So for every new, there must be a delete. So you can see that this is kind of tricky. You have to manage this. So this is called dynamic memory management. And this is a source of many, many bugs.
So when you have a game that has a memory leak, but it only has a memory leak like if you like enter and do a certain activity.
Yeah.
Is that because they've forgotten to delete?
Yeah.
One of the memory calls doing a certain.
Yeah. So in a certain case, in a certain condition, they didn't hit the delete. Then you leak the memory.
That's why you have sometimes you're just playing a game for 4 hours.
Yeah, then because
suddenly it builds up.
Only when you join a group, it leaks a little bit of memory, and you join a lot of groups over 4 hours, so you leak the memory for every group you joined. Yeah, it's not every bullet fired is leaking a memory, but it's like a very specific condition. So this is tricky, right? This seems like wow, this is hard.
Yeah.
Yeah. So this is why I want to transition into the slideshow again, and I want to show you the most important feature of C++.
All right, we're going to you.
Yeah. So yeah, we have something like this. This is the thing that's why I created the player. It's almost like it was prepared.
Oh my god.
Almost. So I have this struct. I have my health and my damage. I have a constructor. I'm happy. Cool. Here's this other thing.
What?
So it looks like a constructor, right?
I use that symbol, the
Yeah.
squiggly line, to describe about.
About.
It's about 50.
Yeah. So this is the opposite of a constructor.
It's a deconstructor.
Close. It's a destructor.
Oh, damn it. I read that from chat and just read it wrong because I can't read.
Yeah, chat is very keen on spoiling things.
Oh. Well, it's a good thing I'm really stupid, so.
So, to show you what that means, this looks like a weird example, but it's fine. So we have our thing, and you can notice that I'm not doing anything on the heap. I'm creating everything on the stack. I'm not newing anything. So this is the old way we did things. So just an example, I put Gabe in a scope. So Gabe is in a little box.
I'm contained.
You are contained. So in this line 23, we are calling the constructor. Think of it like a function. We're calling it. That's how we make Gabe. We make Gabe by giving him health damage. Great. Gabe has been created. But then, remember what we talked about earlier was when scope exits, everything is destroyed and deleted. But then the question comes in, how? How are things destroyed and deleted? The thing is, we call the destructor. Yes.
We need to get rid of him. Call the destructor.
Call the destructor.
Annihilate him.
So think of the destructor just like a function.
Yeah.
The destructor is called when a thing goes out of scope. So this is why it's important that when you have, for example, a pointer, when the pointer goes out of scope, it doesn't have a destructor. A pointer by itself doesn't have a destructor. Just like an int by itself doesn't have a destructor. What happens is they're just popped off the stack. But if it's a class like this, and it has a destructor, when it goes out of scope, it will call the destructor.
So how do you... Is that by just putting the destructor above the squiggly line?
Yeah, it looks like a constructor, except that it never has any arguments. So you can't put... It always has an open-close argument.
Okay.
It never has anything... Because you can't put arguments
So
there.
in main, you're calling me with values 150.
Mm-hmm.
So that's calling it.
That's calling the constructor. That's line 10 through 14.
Yeah. And then when you close the bracket at 24, then it's just doing the destructor automatically. Mm-hmm. So basically, every time I create a constructor, I just pair it with a destructor.
Yes, if you want to destroy something. So in this case, we don't need a destructor.
Okay.
Because there's nothing to destroy.
What cases would we want to destroy something?
For pointers. Because we always need to call delete. So, and then just an example of not using the scope. When the function ends, that's also a scope end. That's why I started by teaching you about scopes, because it leads to this. It leads to, hey, here's here's what the destructor is called. So if we have a class, I'm going to call it the number holder. And by the time, we don't have time to practice this, but there will be time in the homework to practice this. So here's the number holder. And the number holder has what on line 3?
A pointer.
Yeah, pointed to a number.
I almost called it an int. But
Yeah.
technically it is an int.
It's
a pointer.
It's a pointer to an int,
Yes.
yes. And then it has a constructor that takes in the number. I'm guessing it's the number you want to hold. And it has a destructor. Okay? So in the constructor, we do this. It's the familiar thing we've been doing today. We take in a number. We say that the my number, which is a pointer, equals new int. And
which
then
is the number, the value that's being stored in the pointer.
Yeah. So now my number is a pointer that holds a number someone give it. Okay? And then we create the destructor. And here's a simple thing that's in the destructor.
Delete.
Because then when you say number holder, give it a number, give it 1337. And then you can use the number by doing a dereference like this. Oh yeah, and there are other compilers where this is, remember I had to do the parentheses. There are other compilers where they're okay with it. So I did this in a compiler called GCC. So here on line 21, I'm calling the constructor. I am newing the memory. So here, if you look at line 21, even if you never noticed it, there's nothing in line 21 that gives a hint of it, but I am asking for dynamic memory. You just don't know that because that's happening in the constructor.
Yeah.
I'm then using the memory by dereferencing my number. Cool. And then on line 24, here on line 24,
the deconstructor happens.
Yeah, the destructor is called.
Destructor.
Okay.
Deconstructor.
Yeah.
Keep calling it that.
And then because it's called on line 24, we delete the number. So we clear out the memory.
So this is just so we're creating the class number holder, which has a pointer, which is my number. And then it's storing the value, number holder storing the int a number. And that's also, so what's the point of having the deconstructor up in the destructor up in the class?
You need to specify that the class is going to have a destructor.
Okay, and then we create a constructor, which is storing the value of a number in an int. And then you have my number again, which was the pointer that is now pointing to the value of a number.
Or on the heap.
Yeah, it's pointing to the...
Because the other one was on the stack.
Yeah. So now it's pointing to the heap because we've called it new. And that's an int with a number. And then down in main, we're calling number holder. And then naming it holder. With the value. So the name holder, that's just what we're calling it.
Yeah. The variable is called holder.
So we're basically turning a number into 1337. Then we're getting that number from the heap. Because
we're getting it, the value originally is on the stack. Then we ask for value on the heap, space on the heap, and we put 1337.
Yeah, we put 1337 over there. So we're like throwing. Here you go, heap. And then we delete it.
And then we return the number.
So basically, this kind of serves
no purpose.
No purpose other than to throw a number and then delete it.
Yeah, it's to show you that we've just created a class that is using dynamic memory, but we never have to worry about memory leaks. You see, because it creates the number, it creates the memory for us in the constructor, and it deletes the memory for us in the destructor.
It puts the lotion.
Sure.
I don't know.
Puts the lotion in the basket.
That's what was going through my head. Puts the lotion on the heap. Okay.
So, can you then imagine that instead of my number or like the int, that it's a class that can just store anything. And it will basically, this is kind of the idea that smart pointers have, that they will do the memory management for you, and you don't have to worry about the new and delete. And that is kind of the cornerstone of C++ is that you can have this dynamic memory. That's why C++ doesn't have a garbage collector or some sort of memory management thing, because the destructor is what I think the most important feature of C++, because you can create classes like this yourself. The standard library that comes with C++ has a bunch of classes that act like this, that will do really nice memory management for you. You can ask for stuff on the heap, you can ask for all sorts of dynamic memory, and then it will clean it up for you automatically when the scope exits. And that is so important, because with older C++, people didn't do this. So this is called doing a raw new and a raw delete. You're doing new and delete yourself. And a lot of modern C++ talks about that you never do raw new and delete. And what we're going to do going forwards is I'm teaching you about this heap memory, that it's there, there's a pointer that goes to there, how you make it, how you delete it. It's important that they match and all that, but we're never going to use it.
No!
So I taught you all this.
This is like algebra from school!
But it's important that when we start using smart pointers, that they're basically just this. Like, there's a lot more going on and a lot more technical things just to handle all sorts of edge cases. But this is what they're doing. This is their idea that they will do the memory management for you. So you can just say, give me memory, and the dynamic memory or the smart pointers would be like, yeah, sure, here's memory.
Here you go.
Here you go. So, and that's the thing we're going to go into in next episode. We will look at smart pointers, and we'll also look at a thing called a vector in C++. So we're going to look at more standard library stuff. And those are things, the smart pointers and vector are the two most commonly used things in the language, like in day-to-day work. They're just, vector is, it's used so much. So that's next episode.
Nice.
Let's answer we had a couple of questions there, and then we'll go into homework. Okay? Do you need to call delete for every variable in the class and the destructor? Delete health, delete damage. In this one, no. So if you would allocate this one on the heap, you would only have to delete player, because these two aren't pointers. If these were also pointers, if you would have a pointer to a player, and player would be storing 2 pointers, then yes, you would need to delete those 2 pointers. But because these are effectively on the stack, in that sense, on the heap sense, when you delete player, you delete both of these. Is C++ the only language that has a destructor? Are there any other? No, there are others. Rust, Go, I think D also has destructors.
I have a question.
Yeah.
So when you're making a game or a program, it's basically how much memory it needs to use is how often you're calling memory or pointing to things on the heap.
When you're asking for new things, yes.
So if I launch a program,
it's how often you do this.
So that when I look in Task Manager and see a program's using 50 megs of information,
yep,
that's how much
they have newed.
They're using on the heap.
Yep.
Oh, interesting.
Yeah.
Why are my games using so much RAM?
Because the stack isn't very big usually. It's from 1 to like 5 megs. So if a program is using more than that, they're using more memory on the heap.
Yeah. Where is the memory that's being used in the stack stored?
It's in the executable also. It's there as well.
Is it? But is the RAM also?
RAM is both stack and heap.
Okay.
Yeah. Okay. The stack starts at the top and grows down. The heap starts at the bottom and grows up. That's kind of how that works. What's the point of writing an empty destructor? You don't need to write one. The one I just showed that this is a destructor. You don't need to write one. There is one case where you're inheriting a virtual interface. You want to write a destructor, even though you don't need to do anything. But that's just to say that you're overloading it. Okay, you got a feeling that was C++. No, it's the most important feature in C++, even though other languages also have it. but in C++, I would say it's the most important one. It's not the most important feature that only C++ has. No, that's not it. But okay, yeah. Yeah, we don't have time to practice, but yeah, if you can by yourself, please practice this. So homework. Again, homework has 2 parts. The second part is much bigger than the first part. So the first part might be a little smaller. So if you want a screenshot, here you go. First part is practice creating pointers and use all the fundamental types. So make a pointer using double, make a pointer using int, float, boolean.
Double? We haven't used that.
Oh yeah, I haven't mentioned double.
No.
Yeah, float.
Oh, okay.
Double is a bigger float.
Okay.
Yeah, use all the fundamental types that you've been playing with. Just try creating pointers and see what happens when you like create a pointer that stores an int, but is using the memory from a double. Like it won't work, but look at the error messages you get then. Okay. Create a function that creates dynamic memory and returns it. We kind of did that in the generator, but please try out doing that and play with other types. It's kind of important to write that out and see how that works. So that's the only thing for the first part, because the second part is a bit bigger. And it's basically 2 parts. It's 2 classes. The first one should be pretty easy if you have the video and the slides. But the second part is I'm kind of asking of a leap from you. So it's kind of a jump. Okay? So you need to create 2 classes. Class 1, called player, has both health and damage and has dynamic memory. Okay? So health and damage are pointers. It's not that the player is a pointer. It's
so it'd be within the class.
Within the class. Because before we had just int health, int damage. This should be int star health, int star damage. And it can't leak memory. So you need to do the constructor and destructor. Yeah.
Okay. Well, that's fairly easy.
Yeah.
We kind of did that already.
It's just a little bit more.
Yeah.
And then class 2
oh god,
is called combat.
Okay.
It takes into the constructor 2 player star pointers.
Okay.
So it takes in 2 player star. Just player star. And it makes those 2 players fight until one of them is dead.
Yeah.
And then how else is done, how it does it, what the return values are, that's all up to you.
Okay.
So I'm making it a little vague. The only constraint is that it has a constructor that takes in 2 player star pointers.
What is that? Just so I know, what does that look like?
So instead of when you have a constructor that takes in, like we had int health, int damage in the constructor, it would be int star health, int star damage, or in this case, player star, player 1, comma, player star, player 2.
In the constructor itself?
Yes, in the constructor.
So it'd be player, bracket, or colon, player, and then in the brackets?
It would be combat, but yeah.
Yeah, combat.
Combat, colon, combat. And then
player star.
Yeah.
Player 1 star, player 2 star.
Yes.
Oh, okay.
Yeah.
Okay, I didn't. Yeah.
Yeah.
Okay, that's
and then
that's what I didn't understand.
Yeah, and then you make those 2 players fight.
Yeah.
Don't make them fight in the constructor. Make a function that called fight or start or go or something, and then they fight until one of them is dead. And then, yeah, I'm not saying more because there's a couple of tricks here that you need to think about.
Oh god.
Yeah. There's a couple of like holes you can fall into that I kind of want you to fall into those holes, because when you hit a wall and you have to climb over the wall and it's hard to climb over the wall, you remember the wall way more than if I pushed you over the wall.
Goddamn walls.
Is there an easy short answer to the question when to use static versus dynamic? So static versus dynamic. Static is usually if you know the value at compile time. If you're meaning stack versus dynamic, you're basically always using the stack. But if you need more memory than, like, the stack isn't infinitely big, so you're going to run out of stack space at the end, which is called a stack overflow. So
no.
But static is compile time. So if you know the value at compile time, or know what you're going to be storing at compile time, then you can use a static value. There's also in recent C++, you can use a thing called constexpr, And now in 20, there's const eval and const init, if you want to look at those as well. And then, yeah, if you really want to compute something at compile time, if you don't want to compute a thing at runtime. But then you would need to know all the values before you start. But yeah, that's the thing.
Cool. So
yeah. So
we'll be back next week.
Next week we're gonna look at smart pointers and vector, and
do your homework.
Do your homework.
Don't get as mad as I do when you do your homework. Try to be more reasonable than I am. I'm not good at doing homework.
Keep practicing, and yeah, see you next week.
See you next week.
Bye.
Bye.